Welcome back to the Deep Dive. Today, we're tackling a specific mission for you. We're looking at the sources on getting the most performance out of the Tamiya Super HotShot RC buggy, the 2012 re-release.
Right. But crucially, doing it without, well, turning it into a pile of expensive shredded plastic.
Exactly. We've got the tech specs, and we're aiming straight for what really needs changing.
And the philosophy here, it's all about reasonable power. We want that noticeable kick, something satisfying that still feels like a classic brushed motor.
Okay.
But you have to be smart about it. Just jamming in a huge motor, that's asking for trouble. Immediate failure. Guaranteed.
Right. So it's about strategic upgrades. Finding the sweet spot.
Precisely.
Okay, so let's dig in. What even makes this possible? I mean, this chassis design is from '86 originally. Feels like we should start with the stock electronics.
Good starting point. So stock, you get the Tamiya GT Tune motor. It's a 25T.
And T means turns. Lower turns generally means more speed, more power.
And more current draw, yeah. This one's about 19,000 RPM, no load. Decent, but,
But the interesting part, from what I've seen, is the ESC they bundle with it. The speed controller.
Oh, yeah, that's the key. It's a Hobbywing Quick Run 1060. And that little dox is surprisingly capable.
Capable how?
It's rated to handle brush motors down to 12 turns. 12 on standard batteries.
Wait, hold on. They give you a 25-turn motor,
Yeah.
but the ESC can handle almost double the power draw of something like a 12-turn.
Mm-hmm.
That seems generous. Or maybe they just had a lot of 1060s lying around.
Could be. But whatever the reason, the result for us, for you, the user, is that the electronic side isn't the immediate bottleneck.
Okay.
Tamiya basically, perhaps accidentally, shifted the performance limit away from the ESC and put it squarely onto the mechanical parts. The chassis, the gears, the drive shafts.
So we have the electronic green light, basically.
We do. Plenty of headroom there.
All right, so with that ESC headroom, what's the actual motor recommendation? The peak of reasonable power?
Well, the sources consistently point towards the Tamiya Super Stock motor family. They're 23-turn.
Okay, 23T. That's a decent jump from 25T. What does that translate to in RPM?
It's actually a huge jump, around 45% increase over the stock GT Tune. You've got two main options. The RZ, which hits about 27,500 RPM.
Optimize for speed, then.
Yeah, top end. And then there's the BZ, slightly lower peak RPM, maybe 26,500, but it's tuned for torque. Low end and mid-range punch.
Ah, okay. And for a 4WD buggy, something that needs to accelerate out of corners over jumps, torque seems pretty important.
Exactly. That's why the definitive recommendation is the Super Stock BZ. Item number 53930.
BZ?
Yeah, that low-end grunt is what you need for off-road. Launching over jumps, powering through loose dirt, even just getting control back if you start to slide. The RZ might be faster on a smooth, flat surface, but the BZ gives you usable power where it counts.
Okay, BZ it is. But here's the catch I saw mentioned everywhere. Putting that BZ in is apparently pointless, maybe even destructive, without fixing something else first.
Oh, absolutely critical. Non-negotiable prerequisite, really.
What is it? What breaks instantly?
The pinion gear. Period.
What?
The stock one is aluminum .8 module pit.
Right, the little gear on the motor shaft.
That one. And the BZ's torque will just chew through those aluminum teeth almost immediately. You might get one good run, maybe. Then, just powder.
Wow. Okay, so immediate replacement. What with?
Hardened steel, same .8 module pitch, obviously. You absolutely must swap to a hardened steel pinion. Start with the same tooth count as stock, if you like. Maybe a 15 tooth for initial testing.
15-tooth steel. Got it. But that brings up heat, right? More power, steel gear. Are we risking cooking the motor now?
That's the next step. You have to monitor it methodically. The sources mention the 5-second rule.
Oh, yeah.
After a run, carefully check the motor temperature and the ESC too. If either is too hot to comfortably keep your finger on for 5 seconds.
Which is about, what, 160 Fahrenheit? 70 Celsius?
Roughly, yeah. If it's that hot, you're likely overgeared. The motor's working too hard. You need to drop the pinion size, go down to a 14T, maybe even a 13T.
Ah, okay. So it's an iterative process. BZ motor, steel pinion, then tune the gearing based on temperature.
Exactly. Tuned for performance and reliability.
Makes sense. What about longer-term things? When the pinion is sorted, what's next on the potential failure list with that BZ power?
Good question. The next highly recommended step is upgrading the drive shafts. The stock ones are dog bones.
Why?
Under the BZ's torque, especially with grippy tires or during hard landings, they can bind, flex, or even pop out. Swapping to steel universal drive shafts, or CVDs, makes a big difference in durability.
Okay, steel CVDs. Anything else? I saw mentions of like ball diffs.
Yeah, for the really serious enthusiasts, the ultimate upgrade used to be MIP Super Bowl differentials. They handle the power better and offer smoother diff action, but big caveat, they're discontinued and really hard to find now. Very rare.
Ah, okay, so maybe not practical for most.
Probably not. Some also go for aluminum gearbox housings to reduce flex under power, but the steel pinion and CVDs are the main reliability boosters after the motor swap.
Got it. So let's recap. The path to waking up the Super HotShot seems pretty clear and maybe not that expensive initially.
Right. Step 1, super stock BZ motor. Step 2, absolutely mandatory. Hardened steel 0.8 module pinion gear starting around 15T.
Step 3, run it, check temps using the 5-second rule, and adjust pinion size down if needed.
And step 4, for longer-term peace of mind, consider steel CVDs.
It really shows that just chucking in the biggest motor isn't the answer, is it?
Not at all. It's about understanding the whole system, identifying that first bottleneck in this case, the pinion, and then tuning carefully. It's an iterative process.
Which leads to a final thought for you, the listener. Thinking about your own projects, your car, your bike, maybe something totally different. What component, maybe even a small one, is acting as that hidden bottleneck? That one thing you could swap out, not just for more power, but for unlocking the safe, reliable potential that's already there. Something to think about. We'll see you on the next deep dive.